Hello, today we're going to have a look at this light and then we're going to see what we can do to improve it. So let's start by having a look what this light actually does. It has three modes. The first is normal mode or static, not really very interesting. The second is colour phasing mode. And finally, party mode. The problem with party mode is the music has to be very loud before it starts to detect it. So it's not bad as a little gadget, and even a gift, but I think we can improve upon it. So we'll start by taking a look at what's inside. So we've got a battery compartment here, we've got a USB connection here, and we've got the control switch here. Everything else must be on the other side of this circuit board. There's also a little microphone there. So let's take it out and have a look. Now it's quite hard to see what's going on this board, you can't see the tracks, but if we hold it up to the light you can see the following. I've also added some lines to trace out where some of the tracks are going, but we can't possibly work out what's going on from this, so give me a moment while I reverse engineer the circuit. Well, that took a little bit longer than I thought, but we can see now the circuit quite straightforward. There's 4 groups of LEDs, each with their own resistors and transistors to switch them on. They're connected to a microcontroller. I have no idea what it is, there's no writing on it whatsoever. I have a suspicion that it's this PIC microcontroller, but as we don't know and we don't care, it doesn't matter. The right hand side of the circuit contains the microphone logic. This creates logic level pulses when sound over a certain volume is detected. So obviously we need to make some changes. We'll start by removing that unknown microcontroller. Next, I don't plan running this on battery, and the Arduino that we're going to use already has a USB port on it, so we can ignore this section too. The Arduino has several pins on it that can perform pulse width modulation. We don't need to know anything more than we can use this to control the brightness of the LEDs. I've also connected the push button to one of the pins that's used for interrupts. And finally, we need a new amplifier circuit. We don't want pulses, we want actual audio. This little circuit is a microphone preamp. Because it's amplifying incredibly low voltage levels, we need to make sure its power supply is very stable, which is why we've added the 1000 microfarad capacitor. I'm going to build this preamp on a separate piece of strip board. Here we go. So we've got a 1 megaohm resistor, 2 10k resistors, 1 generic transistor, 1 0.1 microfarad capacitor, and 1 piece of strip board. Okay, so that's the preamp connected to the microphone. Time to start with the Arduino. Before we do anything, we first need to remove the microcontroller that's already there. I'm going to use my hot air gun to remove it. And now that it's out of the way, I can solder connections from where the chip was onto the Arduino. Great, so now we just need to assemble it all up and start to program it. So here we are with an empty sketch, and the first thing we're going to try and do is reproduce exactly what the thing did before. So the first thing we'll need to do is configure the Arduino IDE so that we can program the board. This board is connected on COM15. It's an Arduino Pro Mini, and it's the 5V 60 MHz version. So let's start by defining a few things. We'll start by defining all the pins that things are connected on. Next, we'll add some code to make sure that these are configured how we want them on startup. So the first thing we actually need to make it do is respond to the button being pressed. I decided that I was going to do this by responding to an interrupt trigger. Let's add some code for tracking which mode we're currently in. And then let's create a function that gets called every time the button is pressed down. You'll notice that I've added some code to reject a button press if the last button press was within 450 milliseconds. The reason for this is to combat switch bouncing, as we don't want the button being accidentally re-triggered more than once. Next, we need to tell the Arduino to actually use this function. And finally, let's add some code to actually respond to which mode has been selected. Great, let's upload that to the Arduino and see what happens. So as you can see, nothing's happening, but first I need to click the button. And as if by magic, they light up. Did you notice they faded in? That's as a result of the analog write function controlling PWM outputs for us. We don't need to know how it works, we just give it a brightness between 0 and 255. So the next thing we need to implement is the so-called colour phasing mode. This one is actually fairly simple. So we'll add some code to reflect this new mode, and we'll add some code to the main loop to handle this. All that we're doing is over a period of 1 second, we're alternating which light is switched on. So let's upload that to the Arduino and see it in action. You'll notice the first thing that happens is all the lights go off again. So we need to select the new mode. So far so good. Now we need to add the third option, party mode. But before we do that, it's becoming a little bit tiresome already to keep having to reset the mode every time we power it back on. So we're going to use the Arduino's EEPROM to store what mode we're currently on. We'll add some code to fetch the current mode from the EEPROM, and some code to save it when we change it. I'm also going to add some code so that we can change the mode via the serial port as well. So once again, let's start by adding the new mode. And then we're going to want a bunch of variables to hold data that we're recording from the microphone. To ensure we capture audio smoothly, we're going to use an interrupt. We're going to ask the Arduino to call a function for us 8,000 times a second, or 8 kHz. And now we need to define our interrupt handler. It may look quite complex, but there's a reason for that. I want this to adapt to the volume level in the room. So the first thing I'll do is capture 256 samples. From that we take an average, and we can use this average to work out where the centre of the sound is, also known as the DC offset. We then use that to work out how far sound has moved away from that threshold, and then can detect loudness. If we keep a slow average of that loudness, it gives us a value to compare against for sudden jumps in sound. Now we add the code for our new party mode function. The code is very simple. We look to see if there's any sounds louder than the average, and if there are, we use that to create a simple animation to highlight the Pac-Man or Ghost at that particular peak. Finally, we need to add a little bit of code into the main loop to switch on party mode. And now we'll upload it to the Arduino IDE and see what happens. First thing we notice is all the lights are off again. Whilst we've written some code to use the EEPROM to store the current mode, we haven't used it yet. So this will be the first time. I'm now going to switch it into party mode. And this isn't going to do anything without any audio, so let's use the music we used before. Great, well that's as good if not better than the original. But now we've got this far, let's do more. Party mode seems a little bit slow to me, so if we add a speed value, we can create a second effect. We'll add the new mode to the list, and update the main loop for the new mode. Let's give that a whirl. This time I'm using the Arduino serial monitor to change the mode. All I have to do is type in the number 4 and press enter. Let's try this one with a different piece of music. Okay, what else can we do? Well, the previous one behaved a little bit like a VU meter, but I think we can produce a better effect. Once again, we start by adding this new mode, and then we add a new function to handle this. This one's very simple. As it's a VU meter, we don't want it to automatically adapt to the volume level in the room. And we add the code to start it. Let's give that a try. So there's still one last thing I'd like to try. Before we had lighting effects that moved around on motors and span all over the place, discos in the 70s and 80s typically had lighting that was controlled and turned on and off by the frequencies of the music, usually the bass, the middle and the treble sounds. So we're now going to add one final mode that responds like this. But how do we extract the frequencies from the audio? Well, there's a thing called a fast Fourier transformation that does this. You don't want to know the maths. Needless to say, someone has done all the work for us already. However, instead of using an FFT, we're going to use an FHT, which stands for Fast Hartley Transform. Again, we don't need to know how it works, we just need to use the library. The first thing you'll need to do is download the library and install it into your IDE. Once that's done, we continue to update the sketch just as before. We'll start by adding the new mode. Then we add a big function that does the processing. The way it works is, when 256 samples have been received, we push it into the FHT algorithm. The output of the algorithm gives us an array containing strengths of different frequencies. We split that array in 4 and add the values up. As before with the automatic volume, we compute a moving average and a current total. If our total is above a threshold, we turn on the light. Then we fade the lights back out again. The only problem we've got is the timer that's being used to trigger the interrupt is the same timer that will be used for the PWM for the red ghost. So we're going to have to implement PWM manually for that. It's very simple. In the interrupt handler, we keep increasing a number, and we turn on the light whilst our value is greater than this number. This number constantly cycles between 0 and 255 at 8 kHz, which results in the light being turned on and off very fast. This is the basics of PWM. And finally, as before, we add the code to the main loop. So let's upload that and see how it works. If you enjoyed that video, consider giving me a like below. Also consider supporting me on Patreon to help me continue to make more videos like this. I'm now off to play a game, which I think is quite fitting for what we've just done. See you next time.